This conference will now be recorded. This conference will now be recorded.
There we go. Welcome everyone to the Fluids and Materials call today. Praneeth, I don't think we'll be able to join the call because he's traveling, so it's just going to be me running the call today. And basically the idea was, like I said out in an email earlier, I think we just want to review the progress that's been made on the focus groups today. And I attached in an email to everyone earlier the updated version of the PowerPoint, which includes the roster. So we can just start by reviewing that first. I'll share my screen. Okay. So you should be seeing my screen now. I'm just going to make this bigger. Sorry, I'm working on a single monitor today, so it's a bit tricky. So yeah, firstly, just this is the updated roster, which I don't think I had in the last call. If, like I've said in the previous weeks, if there's anyone who wishes to be added to these groups, just send myself or Praneeth or both of us an email, and we'll add you to the mailing list for each of the groups. I've also added on this slide a Google Drive link to the folders that have been set up for each of the groups. I know access can be sometimes tricky with this. I know some groups are working with this and uploading documents to Google Drive. Others are just directly email. I think whatever's most convenient for everyone. It is nice to have information, meeting notes stored in a single place. And yeah, I think if no one has any comments on this, we can just get started in going through each of the focus groups, the progress that they've made. I guess the best use of these calls from now on is, especially, I think it's good to give a general update, but, when you've identified any issues that you want to consult with the broader community, or things especially related to scope or things like that you want to discuss, I think that's the best thing to discuss in this call. We want to keep it like a working call, not just running through updates, and anything that provokes discussion is good. So yeah, for the first focus group, related to the failure modes and effects analysis. Amy, I think you were on the call. Would you be able to give us an update on this group?
Yeah, absolutely. So the work that's been done so far, I would say, is really just level setting on, mostly with the UL team, on what the desired output should be, so that we're focusing our time and effort in the right way. Failure mode analysis can be a big thorny rabbit hole, so we wanted to make sure that what we were actually compiling was going to be useful, and in a format that was appropriate to actually influence and contribute to the IEC. So this includes things like best practices, formatting, different options for paths forward that we could recommend, things like national differences as an approach. The other piece of this is also understanding what the current state is, so doing a more in-depth review of the existing standard. There are two different types of materials that are specifically called out in the IEC standard for materials versus liquids. And they use a combination of limits, meaning targets or numbers you have to achieve, as well as engineering controls. So one of the big ones that I've been working with the UL team with in the past week or two has been to really nail down normal versus abnormal versus single fault conditions to consider. And really what that comes down to is understanding what is the scope of the scenarios of failure that we have to consider for something like IEC recommendations for a standard, versus something like a recommendation for best practices that we might include a fluid or system requirements document from OCP. So it's an important designation to make. One would be, what is an appropriate scope for standards? What is an appropriate versus what is an appropriate scope for guidance for recommendations through an OCP type document. So I've summarized those in a slide deck, and that'll serve as pre-read material for a kickoff, which I'd like to have in the next week or two at the small group meeting. I'm waiting on just a couple of additional responses back and clarifications from the UL team, but otherwise I think we're ready to go. So at a high level, what we've done is a lot of pre-work to make sure that we're working in the right direction once the small team is together. I think the biggest piece of contribution that we'll be having when that small team kicks off, again, is identifying different scenarios that need to be considered, as well as the different temperatures we would expect in and around the tank for that specific failure mode of ignition. The output of it is going to obviously be that auto ignition temperature recommendation, as well as probably some additional engineering controls. And so that's where a lot of contribution from systems design level team members on this call would be useful.
Does anyone
Hi,
have
Amy.
any?
Thanks. Yeah, I see that as a focus on auto ignition temperature, but I think the more critical point of attention is the flash point, which is defined by 62368, which is lower than ours. And there were arguments also towards lowering that. So I'm curious to whether you are purposely not mentioning the flash point boundaries, or whether that is part of the scope.
I would consider sources of ignition, meaning auto ignition and flashpoint, to be in scope for this activity. I don't really think you can consider one and not the other, because it's more of a holistic view of different ways that the system or the fluid within the system can ignite. So Rolf, I would consider both to be in scope.
All right, thank you very much. That answers my question.
Yeah, I would agree with that as well. From what I understood, this was exactly about identifying all the potential failure modes in an immersion system. So that would include failures caused by ignition from external sources. Does anyone have any other comments about this focus group? Questions?
No, besides the fact that I think that your preparation sounds fantastic, Amy. Thanks for that.
Yeah, absolutely. I think, I didn't want anybody to spend a lot of time working and then to find out at the end that it wasn't, the scope wasn't appropriate, the considerations weren't appropriate, or we were thinking about failure modes that weren't even relevant for IEC. So that's really important. I didn't want to waste anybody's time. And at the end of this, one of the desires also is to consider whether we want to expand the scope beyond ignition and into other criteria. So hopefully an output of this also is going to be recommendations for next steps that include, best practices or considerations for other failure modes.
So my only comment would be, I guess, thinking ahead to the 1st of September deadline that we talked about, just to have a submission ready for the OCP Global Summit. It would be good in these initial calls to, just think about scoping for that, I guess. Sounds like it is, even just considering the ignition side of things, it sounds like it's going to be pretty broad and there'll be a lot of work to do. So, maybe just kind of that initial definition and outlining like the challenges, I guess, that could be something that we could bring to the Global Summit.
Yeah, I agree. And Peter, you and I have talked about this as well, that the summit might actually be a way for us, if we can get to a point where we can say, we have this subset of information we've been able to gather from the team on this call, and the people that are in the small focus group, there certainly will be gaps or areas where additional contribution from the community would be valuable. And so if we get to a point where we've been able to say, these are gap areas that we'd like more feedback from the community, I feel like that Global Summit would be a really fantastic place for us to be able to generate that additional feedback, because there are a lot of people that are in the community that can contribute that aren't necessarily on this call, maybe not aware that this activity is going on, maybe just not super active in OCP. And so I think one of the nice things about that is that we'll be able to help fill in our gaps with additional feedback at that forum.
Just a quick FYI, in the power distribution for Immersion group, no, sorry, in the warranties group, we're looking at various potential fail scenarios as well. So there is interest to expand this focus group to also cover some of the aspects related to warranty down the line after this topic is covered. So there's further interest for this focus group to expand its reach and scope.
Great, thanks for letting me know. I actually talked to the warranty subgroup, or sent a note out to the warranty subgroup. Their timing coincides with my staff meeting, so I'm not able to join, but I'll make sure that we stay connected moving forward.
Fantastic.
Awesome. So yeah, moving on to the next focus group, oxidation stability. I think we have Ken on the call to give us an update on the progress here.
Yes, good morning, everybody. Can you hear me?
Yes.
Okay, good. Yeah, so we had a meeting last week, and so that was the first meeting of the group. Good participation. We brainstormed kind of what when we were going to meet and all that kind of administrative stuff, and that'll be every other week. So we'll have our second meeting next week. We also roughed out a list of the potential tests that we can look at, the different oxidative stability tests that we know about so far, and you know, we highlighted the need to be able to find something that can be tested relatively easily. I mean, there are a lot of oxidation stability tests out there. Some require some very specific equipment. So if possible, if we could find something that would meet the needs of assessing the lifetime of these fluids without having to have some of this specific equipment. I mean, if we have to, then that's kind of where it needs to be. But looking at accelerated testing, it's also very important to make sure that we're not introducing anything, any other mechanisms for failure, such as thermal degradation or things of that nature. So specifically just focusing on the oxidation reaction. So the minutes were sent out. We agreed to do everything by email to update folks. I'm having a bit of difficulty with my IT group within Chevron Phillips getting the ability to upload documents to the Google Drive, but they're working on it. So if you've gone to that Google Drive for the oxidation stability group and haven't seen any updates from me, well, that's why. So even before this meeting, we've been exchanging messages on how to get a workaround to do that. But everybody that's on the team has received the email with the different tests and then also the minutes. We also agreed to record the meeting so that just like this one, so if people can't attend, then they can get access to that recorded meeting. And then the last thing is, yes, go ahead.
No, sorry, yeah, just a quick insight from my end. As long as you have something that you can share within the focus group, whether that's Microsoft platform or Google platform, that doesn't really matter. As long as you can, as long as somebody in the group can provide an updated doc on the Google Drive every now and then, that should be fine.
Okay.
So.
Yeah, that's one workaround. If I can't get access, hopefully I can. But if I can't find a workaround, I might ask somebody else on the team to just upload what we have sent by email, so that
it doesn't have to be real time, right? It doesn't have to be real time, just as long as you guys among each other have real time access to the same information that is most relevant.
Great. So that's basically all we have. So people should be doing their homework, looking at the different test methods that are out there, and then should be ready to. Oh, thank you. That's the document there.
Sorry, while you were talking, I was playing around trying to get this open so we could look at something a bit more interesting than just the slide full of text.
Mm-hmm. Yeah. So yeah, that's all we have right now. So we'll be talking this time next week.
Great. Yeah, and so I just wanted to bring this up to show people kind of like the direction we're going in with the review of the existing standards, trying to quantify them in terms of the different parameters of the test, temperature, time, whether they use some kind of gas or catalyst to accelerate the aging, and then what type of test it is, whether it's under pressure, and very importantly the properties as well, that the fluid properties that you're measuring at the end of the test to quantify the oxidation process. Does anyone have any comments to make on this? Questions?
And these all represent comparative results, right? It doesn't really give you a application specific result.
Yeah, these are just the listing out the known methods for measuring oxidative stability. So if we can find something here that would be useful for immersion cooling, it looks like the temperatures for some of them, like the RPVOT or the PDSC, the temperatures may be a bit too high, but we'll see. And we also, we have companies that might have the ability to do some tests in-house in case we want to modify the temperature or modify the catalyst, or whether it's a pressurized oxygen vessel, or if it's just in air. So hopefully we'll come to some sort of agreement on the methodology. We also agreed that we wouldn't set the specifications for the time or the passing criteria. This group is just focused on the method itself, a way to discriminate between what may be potentially a bad fluid or what is a good fluid.
Yeah, Peter, I was just going to describe that there is a whole series of other steps that have to occur once we've established a method, right? This is an accelerated aging test for the fluid in a sense, and then we've got to go and decide what good looks like, what bad looks like, and then attempt some method of correlation to the application, right? So that how long does it take for the fluid to get bad in this test, and what does that equal in the real world? There are a number of steps here that we're again trying to take off small pieces at a time.
Yeah, absolutely. I think the aim would be by the global summit to have this review of the existing methods done and maybe identify a potential test method that would be more relevant to immersion. And then definitely after that, there's going to be those the next steps, like you said, of actually coming up with a kind of pass-fail criteria, or at least some kind of way of interpreting the results, right? Recommendations around that.
Mm-hmm. Yeah, I think that's achievable.
So currently, what's current is subgroups view how would decide a good or bad with a modified oxidation stability method.
I'm sorry, I didn't get that question.
So Ken, I agree that typical RPVOT temperature is maybe too high for the data center applications. Coming from this RPVOT is not really relevant. Coming from different applications in the lubricant space, but when you guys develop and kind of compare different oxidative stability method and propose a modified method for data center, how would you develop good pass or fail, and what would be the standard material for that?
Yeah, so you're asking how will we develop that method in a pass or fail criteria?
Yep.
Is that correct? Okay.
Yep.
Yeah. So at this point, if we can identify a method and maybe the parameters of that method that will discriminate between what the group's view would be as a bad fluid and what would be a good fluid, ideally. And then I think once we have those parameters and that method set, then the broader OCP group can talk about where to set those specifications. And then as Dennis's point, to correlating that to a lifetime. Now, there's some rules for like follow Arrhenius equations on the rate. If you raise the temperature 10 degrees C, you're doubling or tripling the reaction rate. So there's some estimates that we can do to the overall lifetime. So hopefully we'll come up with some correlations there to give people an idea and a way to discriminate between a fluid that's going to last, a couple years and a fluid that's going to last 7 to 10 years.
Do we have a industry target for lifetime of the fluid, for lifetime of the servers?
Good question.
I mean, I've seen 5, I've seen 10.
Yeah, we design our connectors, for example, for those 7 and 10 year marks, right? The EIA standard reliability testing, we're targeting 7 and 10 year marks. That's the best that I could provide in terms of a known industry standard. I know within the OCP community, there's lots of conversation of reuse of servers or second life. And I'm not really sure how that would apply to this, but I think we're talking about the initial purchase expectations, which are for data centers are typically in that 7 to 10 year range.
Okay, thank you.
Yeah, from my experience, yeah, it's also typically minimum 10 years, the expectation for fluid lifetime. But yeah, I think it is a great point and a great question. Maybe Ken, as a suggestion, what we can also think about doing is for the global summit, having kind of like a list of the data that we might need to be able to answer that, right? So that we can put it out there that this is the data that we're missing right now to build those correlations between these test results and like real samples, right? Because we've talked about people potentially having to perform the test, at multiple temperatures to try and build that Arrhenius relationship, work out whether it's a 2 or a 1.8 or a 2.2, right? Things like that. But then also I think the real world data, I know we're not trying to take into account, it's outside of the scope of contamination, but also I think we should at least consider that as well, the effect that contamination might have on the result.
Yeah, asking, go ahead.
Yeah, a question on this, on how meaningful it is to go to that extent in terms of time. The reason why I ask is I think it's very difficult to anticipate what materials will be used in computer systems in 10 years from now. overall, I typically recommend to any end user to do a swap of the fluid when there is a major IT refresh, simply to avoid any potential cross-contamination with different server generations and different materials that may have been used, which may not have been anticipated by fluid manufacturers at the time. But also overall the pollutants that may be introduced to immersion fluid over the years of the lifetime of an IT platform are very unpredictable in nature, because we are talking about mostly open bath systems, and closed chassis would be a different ball game, of course, simply because it's much more controlled when it comes to the fluid quality. But with open bath implementations, shouldn't we just take a point of view that when there is a major IT refresh, that the fluid should be refreshed as well to avoid any unintended contamination per se, and therefore state a lifetime of a guaranteed lifetime of maximum 10 years instead of minimum. You understand where I'm coming from, and does it make any sense?
I'm not sure about the last part. I understand. Yeah, I understand what you're getting at, but I find it difficult to accept a maximum. You know, imagine you had a fluid that was able to somehow magically resist, you know, any kind of contamination and was unaffected by that. It didn't oxidize much at all or significantly over time. Right. To kind of mandate a maximum in that case, I don't think it would make
sure,
sense.
but in terms of scope of work, the complexities that arise when you have to when you have to aim for a much longer lifetime than 10 years, you're going to need to bring in so many hypotheticals in terms of what types of materials may be used in the future. With the if we're looking now at the evolution cycle of IT equipment and the processes within how that's going to manifest itself over a time span of 10 years, that is massive. If you look at the components that are used in server systems today versus 10 years ago, 10-year-old equipment, if you look at that, I mean, it's hardly comparable on many fronts, right? So is it meaningful to put a scope in here or put a horizon that goes beyond 10 years in the future? Is that in any way meaningful to focus research on and potential aging or other effects of the fluids?
Well, I think ultimately we want to be able to discriminate between a fluid that is only going to last for a short period versus a fluid that's going to last much longer. The 7 to 10 years may be a bit ideal, and I think your point is a very good one. That in actuality, would you have fluids that are in constant use for that length of time, and maybe would they be in constant use without some sort of monitoring of acid number or contamination or what have you? And then, would people not change out the equipment as updates come along? I'm not sure, but I think in general the target of coming up with a method to help people discriminate between different performing fluids may still remain the same.
I understand where you're coming from, but then again, I also want to personally, I will be very hesitant of putting an impression out there that it would be a good idea to use fluids for longer than 10 years, right? Yes, 10 years. There are plenty of server environments that will last for 7 years, maybe even 8 years. 10 years is already pretty far beyond the practical lifetime of any type of IT equipment. And is it really wise to give the impression that some of these fluids should be used for longer than 10 years? Because I don't think that would be a good best practice anyway. I understand the quality angle with it. Yes, sure, we're dealing with very high quality fluids, and you may want to distinguish between fluids that degrade over a time period of 3, 4, or 5 years versus 10 years. And yes, I think I do see the value add in terms of a quality spec, but putting anything beyond 10 years, considering the fact that I don't think there is a single fluid out there that has actually been used for more than 10 years continuously. What type of reference do we have to refer to that? If there's no practical scenarios where it has actually been done. So I'd be very hesitant on putting anything in any kind of document that aims for a 10-year life without any physical or historical evidence on that. Yeah. Besides the practical points that I already mentioned.
Yeah.
I mean, I like to think in analogies, and you know, the oil in your engine, right? And the standards have changed over time, but now we're at somewhere between 7,000 and 10,000 miles for many engines that you replace the oil. That doesn't mean that you can't drive the car. My dad many years ago drove a car 40,000 miles and never changed the oil until the engine seized, right? So, but you could drive a car significantly longer with the oil. In this instance, it may be possible to use the fluid for many decades, but to Rolf's point, I think it doesn't necessarily make sense. There's you're going to have a standard of some level of cleanliness, right, of the fluid, whether it be via contamination or oxidation, and you're going to say, it's best practice to swap out the fluids or refresh them or filter them, or I think there's many options here as you're replacing the equipment in the fluid as well.
Yeah, and don't forget the open bath nature, right? So the human interfacing with the fluid in open bath systems, every time there's maintenance, there's people interfacing with the fluid, getting their hands in touch with it, contaminants being introduced that you cannot predict, right? Absolutely zero can be predicted from that. Whether somebody has just changed the oil of the car and introduced some pollutants from their car oil, or whether somebody spilled a cup of coffee in it without mentioning it, and those things may not be measurable over a decade, but overall it does have an impact on quality. So the air quality that may interface with the fluids as well, that is also a huge caveat. You don't want to go down the line in designing guidelines for like X-ray level for air quality with immersion systems. So the type of deployment variations that you need to take into account are so numerous that I don't think it would be good. It would be good to insinuate fluid as being impeccable when it comes to these kind of unpredictable conditions. I think we need to be very realistic in terms of what you can and cannot promise or guarantee or practically do with these type of fluids. And again, it's different in sealed applications, right? Because that's where you have a very controlled environment. But open baths are just not controlled environments to that same extent.
Yeah, and my concern is mostly just having an eye on the prize for everybody on the teams, whether it's FMEA or the oxidation rates or any of the other things that we're trying to do. It's like we're obviously industry focused, but let's make sure we pick the number that industry is going to like, whether it's low or high or whatever, but that we have one that's consistently stated, and that it doesn't shift in 6 months or 3 years after all this work's been done.
Yes, in terms of all these considerations, I like the 10-year horizon, but I would strongly advise to put in a whole bunch of caveats around it that doesn't include cross contaminations or poor air quality being interfacing with the fluid. And if you do refer to that there might be that there is at least some kind of an analysis of how that may affect lifetime of a fluid, that sort of stuff. But anything, in my opinion, anything that you scope out beyond the 10-year horizon, I would treat with a lot of skepsis.
Rolf, I think you brought up an interesting point right there, and maybe, and this is for discussion, of course, on the oxidation sub-focus group too, of, you know, maybe the approach is, you know, don't worry about it until that 5 to 7 years, at which point the recommendation would be to conduct testing on the fluid at every 2 years after that. If you choose to maintain that fluid in your system, then the recommendation would be submit that fluid for XYZ additional analysis every 1 year or every 2 year after that, to ensure that, kind of like the oil change in your car example, you know, you don't want your engine to seize, but the oil probably is fine beyond that 7,000 recommended. So maybe the solution is don't worry about it up until 5 years, at which point, or 7 years or whatever that number is, at which point the recommendation would be to submit for XYZ additional testing on an annual basis to ensure that the compute won't be damaged and performance won't be impacted.
Yeah, and also adding, I agree with that approach, and also adding when there is a full IT refresh, that warranty of service should be evaluated as well, because if we're looking at the fluid specs right now, everything is aimed at new fluids which have high purity, which do not contain any contaminants yet, and that is obviously doesn't apply to a fluid that has been used for 5 years, which is where you get into the warranty domain as well. So there might be, I think we can fully expect that to be a link between IT equipment warranty and the use of fresh or new fluids over time. Even though that's predicting the future, but I think that is the most likely scenario for IT equipment warranty.
I had a quick question about this. Does this apply to like just base fluids only, or does these standards also apply to fluids blended with either like antioxidants or you know, fluids that are blends of different base fluids? Because if you imagine like you're applying a simple Arrhenius, you know, relationship to this reaction, if you have other factors in there, like it's going to change that, you know, that relationship. It's not going to be straightforward, right? Because you're not just oxidizing the you know, the one type of you know, carbon chain. You're consuming the antioxidant first, which is at some rate, and then you'll be oxidizing the hydrocarbon. So that's another rate in that example. But you could imagine that getting more complicated as you have different sort of fluid chemistries and whatnot. So I was just wondering if this is broadly applicable to different things, or this is mainly, you know, relatively pure base hydrocarbons.
Yeah, I think we have to look at both neat materials as well as additized materials, and you know, as Peter mentioned earlier, looking at different temperatures. So, I mean, if you have one fluid that is exposed to a much lower temperature than another one, then you may need different levels of you know, oxidative stability, because you know, if things are going to be cooler, it's going to oxidize a lot slower, and getting a method so that we hopefully can give people an ability to estimate, okay, this fluid in this type of system at this temperature, you know, should last some factor longer than if it was at this temperature, or if it was additized with certain antioxidants or what have you. So I think it has to be something that's generally applicable, not specific to just the base oil.
Yeah, question here. Can we expect the manufacturers of immersion fluids to disclose their base fluids, the base oils, for their market products?
I don't think it. If you're just testing the fluid, then it may not be necessary to disclose that kind of information. You're just testing the fluid on the merit of the fluid itself, whether it's additized or not, or whatever the nature of the chemistry of the base oil.
So why distinguish between various base oils then? Because I can imagine if manufacturers are not necessarily willing to disclose which base oils they're using, how valuable would be distinguishing between base oils as well as the eventual products? It's a genuine question, right? So it's not rhetorical in any way.
Mm-hmm.
What kind of disclosure do you mean, Rob? Like you mean in a data sheet or when they're doing a specific test?
Yeah, if you want to be looking at the merits of different base oils or base fluids, is that meaningful if nobody is disclosing their base fluids?
From my
Or
point of
do
view,
them,
like this
yeah,
should be kind of like a blind test, or in a sense, not. It should be universal. It should apply to any fluid that you submit, right? And then the result will be the result.
yeah, right.
Rolf, the only way that
That's
I could see it maybe impacting things is if for whatever reason there's some kind of limiter or target for something maybe like a change on the IR, like looking at the degree of oxidation that occurs based on a change before and after oxidative stress is applied. Something like that starts off as like an ester or has an ether in it that already has oxygen bonds. That peak will already exist at the beginning, so the delta might have a little bit more bounce. That's the only way I could see it really being that impactful, is if eventually some kind of a target is set by our team, to say you're looking for a delta less than XYZ as a result of stress testing. You might see a little bit more bounce depending on the starting fluid composition, but I wouldn't anticipate that anybody would set that actually.
Okay, thanks.
And from a connector point of view, we're going to need that to apply to the electrical characteristics of the fluid as well, right? The decay value, those change, if they do, through the aging of the fluid, that will affect the data rate and performance of the connectors. So that needs to be taken at some point here as we move forward. That's another variable that needs to be thought about in terms of the aging of fluids.
Yeah, I've have like 3 buckets outside of contamination that I think of for fluid is cooling performance, dielectric performance, and safety profile, environmental safety profile. And so I think in the end, for both the FMEA and for this, those are the things we're looking at, right? Like what kind of impact happens.
Yes.
So yeah, I think it's been a really good discussion. Maybe we can draw a line under there. I think that's been really valuable feedback for Ken and the rest of the team. We are running out of time today I think to go through all of the other focus groups. So maybe in today, we can just try and see if we can finish up with another 1 or 2. So I'm going to go back to the presentation. So I can move on to the 2B, the component level material compatibility. Max, I think you were the one leading this. I don't know whether you've been able to meet with the rest of the team yet.
Yeah, we're still also aligning internally, but we'll get our stuff together. It's been lot's been going on, so we'll get some stuff together for next meeting.
Okay, if you need any help like setting up meetings or getting access to anything, like the drive or whatever, just let me know.
Will do. Thanks.
Cool. So yeah, moving on to the next one, the cleaning procedure 3, focus group 3. I forget off the top of my head who was, well, I don't think we appointed a leader for this group. I know the participation was pretty low. I don't know if anyone has met. If I go back to the roster. So we had Chris Karolka, who I think I just got a message earlier that we might need to remove him from this group. Joshua Garner, Jack Kohler, and Amy, I added you in there as well. Okay, I don't think this has been kicked off yet. I think Pranith and I, when Pranith and I reviewed this the other day, we mentioned that we might add in some material to kick things off, at least between the participants of this group. So yeah, we'll come back to this and see what we can put together. If there is anyone on the call who wants to join in that, please let me know. So safe handling of fluids, Spencer, I think I saw your name on the call earlier.
Yep. So we had our second meeting. I think last meeting I shared that we had kind of outlined the scope that's captured here as well. And so we have a working document right now with some contributions on the chemical handling guidance and IH monitoring and product stewardship. So I think we'll just be looking at our next meeting to get more as far as regulatory guidance with codes and add that to the document and just keep fleshing it out from here.
Would you be comfortable sharing the document, the notes that we've been putting together, or do you think it's a bit too early?
Yeah, maybe at the next meeting, I think that we could do that.
Okay. Is there any specific information that you'd like to ask, input, guidance?
I don't think so at this point. We got some feedback last time just about making sure we included something as far as just a routine cleaning procedure that people can start enacting soon. That's kind of, I guess, separate from, this is more for cleaning the fluid rather than cleaning the server components in the other subgroup. So we'll work on adding that in as well.
Awesome. Does anyone have any comments on this focus group?
Is it some region specific? Because I heard it could be also depending on what jurisdiction, they might have a different guideline or different rules. How are you guys covering those?
Right. So some of that will probably come up in maybe some of the code requirements and kind of allotment of, storage of how much fluid can be at a site. But I think that we'll have to see what we're looking at as maybe defining the scope as far as the building codes a little bit better in our next meeting. Hopefully we'll hear about that today.
Awesome. So on to the next one, 5A, the functional server component level compatibility. Max, I think this was also, you were also appointed leader of this one.
Oh, I think this is Samantha, but yeah,
Okay.
I'll talk to Samantha about this and see where we're at. I think she's waiting on the, or we're needing to align internally about a lot of stuff in terms of like what we're like what materials we can share and whatnot. So yeah, we'll get back to you about this.
Okay, great. So yeah, it looks like we do have time for the last one, which is a tank level compatibility. Phil, I think you were leading this before, and then you passed the baton on to Thomas Crandall. So not sure, Phil or Tom, if you want to speak to this one.
Yeah, sure. I missed the last meeting. and so I think Tom ran that one. I think we were making some pretty good progress. I think, but yeah, Tom, if you want to speak to what was discussed at the last meeting, I think that'd be fine.
Yeah, the last meeting, the previous one, was postponed because of late attendance. So we'll have another one this Friday, I believe. But we were setting scope and kind of direction towards testing and test methodology, and kind of aligning that with previous papers that have been done. But yeah.
So based on the previous discussion, it seemed like you were looking for a bit of guidance, I guess, around the scope on this one. So Praneeth and I put together this slide, and if you just look at the objectives, do those align with the discussions you guys have had? Do you agree with them? Do you want any clarifications?
Yeah. So one of the things that had come up was how granular do we get down into testing? Because when you have various, we could select different materials and we could say these materials are appropriate, but when you get an entire system and you put all the materials together, sometimes they can have secondary or tertiary kind of effects between materials, and that kind of seemed like a bit too much to probably tackle. So we were discussing a couple times, a couple meetings ago, about can we keep those at kind of a first level effect and capture everything, because otherwise it could balloon quite a bit to try and capture all materials and different ratios of materials and things of that nature.
So here's where, and this is just our point of view, so feel free to disagree, but here's where Praneeth and I saw potential overlap with the document we published last year, which was, let's call it like an individual material level test methodology. And we also published like a table of compatibility results from some of the most common fluids. Now we've also got the other focus group, which is looking at component level compatibility, and I'm assuming we'll be coming out with some kind of test methodology as well. So I don't think it makes sense to be looking at creating another methodology around testing individual components or materials that come from the tank. And that's why in terms of the objectives we put together, we thought it was more useful to the community to actually focus on coming up with, for example, a list of wetted materials for tank components, specific to tank components. And based on that, also provide a list of recommended materials, right? Like whether it's tank materials or piping, O-rings, that sort of thing. And then the third thing we thought of was how to address failures due to incompatibilities. So if you do have some kind of incompatibility inside the tank, what would be kind of the response to that? 4, which we highlighted, was a test methodology for a tank level compatibility test. But there, this is kind of just my vision. There it would be more about you've assembled all the components for a tank and you want to kind of do a final check of compatibility. What would that test look like, right? It's kind of equivalent to a dunk the server type of test.
Okay. Okay. Yeah.
I don't know if anyone has any thoughts on that, disagrees.
Yeah, I know we're at the top of the hour, but I do, I think we really focused so far, and mostly on number 4 actually, which is more tank methodology. The wetted materials, And recommendations of materials recommendations I think could be a little challenging, but I think the group, we can continue to work on that as I'm available, but I know Tom can drive it. But I think we've mostly focused on number 4 in the group, and that's, how would we test it as a tank level? And we've already been defining components and their wetted materials. So I think we're on the right track for 4 and 1, but I don't think we've addressed 2 or 3.
Okay, so maybe, yeah, the next call we can maybe start with this and then maybe look for some feedback in terms of what would be most useful to the community.
Yeah, exactly.
Cool. So with that, yeah, we're a minute over time now, so I'm going to close the call. Thank you all for attending. And
hang on for a second, Peter. I do have a last support request that I would like to put to this group, if you're okay with that.
Yep, sure. Go ahead, Rolf.
All right, good. Well, thanks for that. As you've probably seen in the announcements, we've finalized the immersion requirements, the first amended version of the revision 2. One of the things that is still open for me to do is to run an analysis on figure of merit numbers and to analyze the potential curves that it takes, or the type of trajectory that a graph would take with different temperatures. But before I can do that, I need some sample data to work with to analyze how figure of merit develops, whether that's linear, whether that's curved, and if curved, what type of curve would be typical for that. And so far, I still have, despite some earlier requests, I haven't received any sample materials. So let me just share my screen for 1 minute. The spec sheet that I distributed through the mailing list alongside the new immersion requirements document contains this tab with fluid specifications. I would like to ask for some sample data. It doesn't have to be the actual immersion fluid, but as long as I have some data on how for this table, which are realistic numbers for any given type of immersion fluid, and it can be anonymous. It doesn't have to relate to a specific product, but I would like to be able to use that data to extrapolate figure of merit numbers against temperatures. So if it would be of great help if I can receive some sample data that I can use to determine some appropriate formulas for getting figure of merit numbers for intermittent temperatures. Direct relation to this is, for example, the fluid spec, which contains which requires a reference of 25 degrees C, which we don't require in immersion requirements, but to extrapolate that figure should be easy to do, but I can only determine appropriate extrapolation strategies if I have sample data to work with. So if you're willing to help out, please send some sample data to me directly. I will treat it as confidential and anonymous, but I will only use it to do some of these calculations and get some estimates of how it can be done. That's the call for support I had, and if somebody has any additional questions on this, I'll be able to stay a couple more minutes on this call, but for the rest, please contact me with any information that I can use for this purpose.
Hey, Rolf, I didn't receive anything from you for a call for, so I don't know if I'm not on the right distribution list or not, but if you can resend it, I'll be, we can look and see what we can provide.
Sure, Phil. I think I mentioned that also with the. Are you on the immersion mailing list? Because that's where I shared the new immersion requirements doc.
Yeah, I think I'm missing from some mailing lists. I don't know when things changed hands. I think
All right.
So I can go ahead and try to
I'll send you a message with the subscription links for the Immersion mailing list. It's the whole project mailing list, which is not used for spamming and operational communications. But it's good to be subscribed to it also for the monthly meetings. I'll drop you a message, Phil.
Right. Thanks. Appreciate you.
Anyone else?
I'm sending you something right now.
Thank you. That's greatly appreciated, and especially if that can be, if you can share information with the actual spec sheet. That would be fantastic, because then I can just translate it. Then I don't have to figure out what to put in where.
That's the next time. Yeah.
You're setting me up with homework now.
Then next time I'll put it in the data sheet. So, but this, I have something already I can send you right away.
I appreciate anything you can share. Fantastic.
All right, cool.
Great. So if no one has anything else to comment on, I'm going to stop the recording now.